We are on the page 14, section 2.1 to 2.5, solving a linear equation. So this class, we are going to learn three things. This is the first one, solving a linear equation and an inequality. So we see what they are first, then what we are going to do with it. This part is very important. You need to practice a lot. Otherwise, you will have a problem later on because everything is based on this. If you cannot solve the problem, you cannot graph the line, then you won't be able to do the class. So this part is the foundation of everything else. Okay, so we want to know how to solve a linear equation. So before we know how to do it, we need to know what do they mean, right? So we start to explain what are those. And we say on your page 14, a linear equation in one variable. We just do the one variable, okay, for now. So linear, what do you mean by linear? It's kind of like a line, right? So the way we describe it is what? The highest power on the variable is 1, right? We see what does it mean. And it is also called a first degree equation. So what do we mean by the highest power on the variable is 1? So we have a variable, right? So if I have this one variable, if I write x, means power of what? 1, invisible 1. If I write x squared, means what's the power? That's the square, right? Second power. We say the highest power on the variable is 1. That means x only has 1 power. And for a linear equation, the highest power on the variable is 1. It's an equation, right? So if I write it this way, equation like 7x minus 3. If you just have one side, for that we call it what? Math language. It's called expression, right? When you have an equal sign, we call it an equation. So for an equation, if power is 1, then it is a linear equation. For the second one, if you have this, do we have an equation? Yes. What's the power on the variable? It's 2. So is this a linear equation? No, we will not say so, right? If we have this one, for the third one, you have 3y plus 8 equals 6 times y minus 4. It's not simplest form because you have parentheses and bunch y everywhere, bunch of numbers everywhere. But we will call it a linear equation. Yes, because the power on the variable is 1. So first we describe what is a linear equation. Then we see some examples, then we identify them, right? Then next we are going to solve it. Solve it means what? to find an answer or answers, right? To solve means what? To find all the numbers, right? All the values of the variable, right? For the variable, if you solve it, that means it should work, right? So all the values should work, right? That means what? Because we have equation, so we have equations, so which will make all those equations your truth, right? It has to be correct. So if we find the answers, so that means what? X equals something. Then we find the answer. That means we want to get what? X equals something, right? Some numbers. So that means what? We need to get the variable by itself on one side. Is that right? Otherwise, that's how you wouldn't find the answer, right? So we will get the variable by itself on one side of equation, right? Like this, then you say, oh, X is that. Then we find the answer. Let's see some examples, then see how we actually do it. So, if this is not on your table, I mean on your paper, not on your paper. Say, if I have a 3, say X equals 12. What do you think that the X would be? 3 times something becomes 12, right? So your X should be what? X equals 4. But how we are going to do it systematically when the situation is complicated like this? So we want to get X by itself like this, right? Then 3 times X, you want to get rid of 3, right? Because between 3 and X, it's a multiplication. So what do? It's a multiplying, get a number, so you will do what? Get rid of 3 by doing the opposite, divided by 3. So if you divide it by 3, then you can get X by itself, that would be 4, right? So what we do is, we will do one side, we will do another side. So it's like equation, it's like your balance beam, right? So if I say, okay, if my X is 5 pounds, then my 3X would be what? 15 pounds. To be balanced, right? So if you do one side, if I say 3X is 5, it's a 15, and I want to find the X, that means I take 1/3 of it. So if I do one side, I need to do another side. So to keep the balance, to keep the equal sign. That's how we get X by itself. So when we do it, we will do into one side of the equation as you into the other, right? So you use inverse operation into each other. That means if you multiply, then you do the opposite by dividing. If you do the addition, if I say X plus 5 equals, say, 15. What's my X? So I take this 5 away, then I take another away, so you make the equal sign stays, right? So X becomes 10 that way. So what we do is, we call it golden rule, and which is not a formal term of math. We just help you to remember. Golden means golden, you need to follow. okay? So we will do one side, you do another side. Then you get x by itself on one side, get x by itself on one side, then you find the answer. But situation like this, more complicated, what do? We need to simplify from each side before we do it. Okay, then you get x by itself. So if I have two, this is not on your paper. So if I have 2/3 of x equals what? 6. What's my x? It's not that obvious, right? So actually it's 9 because you cancel out 3, then times 2, that's your 6. How do we find this example? Find the answer for this, right? You do the opposite. So opposite of 2/3, they multiply. Instead of dividing by 2/3, what do? We want to neutralize 2/3, right? Get x by itself. How do we make 2/3 go away? You multiply its reciprocal, remember, right? Reciprocals, when we multiply each other, you get what? 1. That's what we want. Get x by itself, 1x. So if you do one side by golden rule, you do another, which is 3/2, right? Those cancel out. Then how do you multiply your fractions? Put 1 underneath, cancel out 3 and 1, then you get what? X is 9. Get x by itself. Okay, then we see how we are going to handle the situation when it's more complicated like this. All right, let's see some examples. On the bottom of the page, page 14. So the first one, it is 2x minus 3 equals 11. If you look this one, before we try it, let's just guess, okay? What do you think? Guess. Not that obvious, right? But let's see. If x is 7, would that work? 7 times 2, 14. 14 minus 3 is 11, right? That will work. Simple one you can guess, but complicated one will not be so easy. So we wanted to do it systematically, okay? So what do is we simplify each side of the equation, then get rid of all the parentheses and make each side simple. Then we do the second step, right? So this one, so you put a line in between. Both sides are simplest you can have, right? So we say we want to get x by itself, just by itself on one side. So which one you have to move away? You have to move away 2 and negative 3, right? But closest one, you move away the last. So what do you want to move away first? The further away one, okay? So we want to move away negative 3 first. Then by inverse operation, negative 3, we want to do it, so we do plus 3. So we can get rid of these 3. You do one side, you do the other side. We call it golden rule, right? So this side end up what? 2x equals 14, right? Then we want to get x by itself. We need to get rid of what? 2. But between 2 and x, it's a multiplication. So we do the inverse operation, which is what? Division. So you divide it by 2, right? Then you can get x by itself. That would be what? 7. Most of you would be okay, but somehow some of you may get confused for some reason, right? So make sure you just follow the steps and practice until it sinks in. Let's look the next one, number 2, right? We say you want to get variable by one side and the number to another side. Before you do that, you want to make each side of the equation as simple as possible before you move things around. Okay? Otherwise, you get confused which one is which. If it's the simplest one, it's obvious by then, right? So how do we simplify on this side? We call it what? Combining like terms, right? So those are like terms. -3, -4, total is what? -7n. You need to take care of your signs correctly, right? So you draw a line so you know one side and another side. Then you move the number away to the right hand side. So you -2. So what do we have? This side will be -7n equals 23 minus 2, 21. We move numbers to another side. Then this side only has the variables, right? Then we need to get rid of -7 by doing what? Multiplication, do the opposite by dividing, right? So this cancel. So your n is what? -3. How do you know you are doing right? What do you think? You just put back the value, plug back in to the original one, see if it works. Like this one is a 7, so I plug back in. 2 times 7, 14 minus 3. Yes, I get 11. Same thing as this one. You have more negatives, but you can try it to plug in, see you actually get 23. Let's see next one. Number 3 on your page 15. So how should we start? How about draw a line, right? Then simplify each side of the equation as much as possible, right? Remove the parentheses and combine like terms. So for this one, you can combine like terms. 2 minus 3, -1y. -1y is the same thing as a -y, right? -5. Then this one will be what? -14. Then, since y is already here, I can just leave it there, right? By itself, because it's already by itself. I can do what? I can move 5 over another side. I can do that as well. Okay? So I can add a 5, do the opposite operation. So you can get rid of that -5 by doing that. So that will have -y on this side. And for this one, -14 plus 5 is what? -9, right? Did we get y by itself? Not quite, because you have a negative there. So we need to eliminate that as well. By doing what? Divide by -1. That will work. So you can get a y by itself. This one will be negative and negative becomes positive. That will be your answer. Got an idea? Okay. Let's look at the next one. Both sides have a and number. You can move to either side. Okay? Usually we move the variable to the left hand side, the number to the right hand side. So I will move the number away by doing the opposite, right? So that goes away. We have 2a equals what? 7a. Oops, typo. So negative 3 minus 5 is what? Negative 8. Is that right? Then what should you do? You need to move the variable to another side by doing the opposite. 7a, to take away from it, you do minus 7a, right? Then what do we have? 2 minus 7, negative 5a equals negative 8, right? Then, to get a by itself, you need to get rid of negative 5 because they are multiplying each other, so you do the opposite. So what we have now, a equals what? Negative divided by negative is positive. That would be your answer. Right? So, what are we doing? We call it solving linear equations. Right? That's how we solve it. We do what? Combine the like terms and we follow the rules and get an x by itself. Let's look at the number 5. So how should we start? Draw a line, right? Move numbers to another side, move the variables to the left hand side. Usually we do that. So let's move the number away by doing what? The opposite. Right? So this side would be AZ, this side would be negative 2Z, and negative 6 minus negative 14 is minus 20, right? Then we move the number to this side by doing what? The opposite, right? So we get the variable by one side, number on the other side. So that would be negative 20. And this one would be what? 8 and 2 would be 10z equals, right? Then get the variable by itself. Get rid of 10 by doing what? The opposite, right? Divided by 10. So then we can get the variable by itself is negative 2. That will be your answer. Take a quick look to check. Negative 2 minus 8, negative 2 multiplied by 8 is what? Negative 16 plus 14. That would be what? Negative 2 on this side, right? Then on this side, Negative 2 times negative 2 minus 6. Negative 2 times negative 2 is what? 4. 4 minus 6 is what? Negative 2. So they are the same. So that's how you check. Right? So, next one. Number 6. This one is a little bit more complicated than before. Right? You have what? Parentheses. So you need to remove it and make it simpler on each side. That's what we learned earlier to simplify, right? The expression by removing parentheses, right? We distribute, or we say distribute, right? So that would be what? 7 plus 2c minus 2 times 3, 6. On this side would be the same. Then after this, you will combine like terms. So 7 minus 6 is what? 1, and 2c equals 5c plus 10, right? Then we will move the number to one side, to the right hand side usually, right? So those cancel out. 10 minus 1 is 9. Then you copy other things. Right? So, oops, don't forget your plus sign. Then, what do? Move the variable to another side by doing what? The opposite. Right? Then 2 minus 5 is what? Negative 3c equals 9. And get c by itself by doing the opposite, right? Multiplying, so you do the opposite, is dividing. C is what? Negative 3. That would be your answer. Start to get into it. So it's quite important you can do those. Otherwise, you won't make the class. Okay, you do need to practice a lot and hands-on. So before we move things around, get a variable by itself, we need to make it simple first by simplifying, right? With combining like terms. So like this one, we get rid of parentheses first. So that will be 4w here plus what? 2w minus negative, right? 2. Right? On the right hand side, that's a 6. And negative, you need to distribute your negative. So that would be what? Minus w and change the sign, minus 2. Right? Then combine like terms, make it simpler. So that would be what? 4 and 2 would be 6w minus 2 equals what? 6 minus 2 would be what? 4 and minus w. Then, what are we going to do? Move numbers to one side, right? By doing the opposite, plus 2. And those cancel out, those are 6, right? Then what do we do? Move variable to another side by doing opposite, right? Plus W. So we have what? 7W equals 6. Then to get the W by itself, to get rid of 7 by dividing, so your W is what? 6/7. Right? Let's see what's happening here. What's the difference between this one and the previous one? Right? Previous one look much better because those are better numbers. Now we have what? Fractions. Do we like fractions? Most of you, not quite, right? So for the things we don't like, what can we do? We can get rid of it, right? By what? Which method we can get rid of the fractions? Because of this equal sign here. So if we do one side, we do another side. So for us to get rid of fractions, for 3 and 2, which number we can multiply by, then 3 and 2 will be gone, right? So we use what? 6. That means what kind of method we are using to get rid of fractions to solve problems? And look your earlier for the part A, say strategy for solving equations involving fractions. What do? We will multiply both sides of the equation, right? Of the equation by what? LCD. This way, we can remove the fractions. If we do that, see what will actually happen. So, if you multiply by a number, you need to multiply everyone with same numbers. Okay? So, you have x cubed, x third times 6 plus 4. 4 times 6 and x half times 6. Right? How do you multiply your fractions with numbers? You put this one you don't need because both are whole numbers. And this one, if the one underneath, then you can cross cancel. Right? Then what do we have? We will have 2x plus 24 equals 3x. Is that much better? Definitely. Then since the number is on this side by itself already, so we can just move x to another side by doing what? Minus 2x, right? Then this cancel out. 24 equals what? X. That will be your answer. Manageable, right? For fractions. Look the second one. So for both sides, you have what? 2, right? Fractions. This side, you don't have any. So what do? Multiply everything by 2, right? So on this side, when you multiply by 2 times this original one, and this side would be what? 3x plus 6 times 2 as well, right? Then this side, 2 times, put 1 underneath, you cancel out this, right? Then what do we have? We distribute the 3. So will be what? 3x minus 6 equals, you multiply them, that will be 6x plus 12, right? Then what do we do? You move number away from left hand side by plus 6. Then that would be 18. 6x plus 18. This side would be what? 3x. Right? Then draw a line in the middle so you can see better. Then you minus 6x. So what do we have? We have a negative 3x equals 18. Right? Then get x by itself. So what do we have? We have x is negative 6. Is that right? So what did we just do? Solving linear equations, right? Equation with what? The variable power is 1. With what? Fractions. As long as you get rid of fractions, it will work the same as, earlier, right? Just regular numbers. So you move variable to one side and move the number to another side. Then you solve x, get the variable by itself. Practice. It should be okay. Okay? Look the next page, page 16. We are going to solve different kind of problems. Take a look. If first one is this one on your page 16, right? What do we have now? Instead of fractions, we have what? Decimals. Don't worry about the method. We just do it directly. Instead of doing things like fractions, get rid of fractions. Instead of getting rid of decimals, we just do it directly. It would be much easier that way. Okay? So, I'm going to move number to one side, move the variable to another side. Okay? Let's just stay that way first until you get familiar with, you can move however. Okay? So, we'll minus this to the left hand side, right? The variable. So what do I have? How am I going to subtract 0.2 and 0.04? Remember how to do your decimals? This is m, right? The variable you keep there, you do minus the decimals. So you lined up with what? Dollar to dollar, pennies to penny, right? For the decimals. So not enough an empty space, you put a 0 there. You can only subtract from the larger one to the smaller one and decide the signs, right? So borrow, so that's 6, right? So that would be 0.16 n. Plus 32 equals 0. Then what do we do? Minus 32 on both sides. What do we have? 0.16 m equals negative 32, right? And to get m by itself, what do we do? Divide it by 0.16, right? Negative time divided by positive is negative. Remember how to do your decimal division? 32.16, right? So, how should we start to do the division? You need to treat it as a whole number by moving the decimal 2 places. So this was here, then it will be right here. The empty spots, what do? Fill up with 0. And your final result, the decimal point should be right above it, right? Then you can treat it as whole numbers to do it. 16 can go into 32 twice. Then until you reach the decimal point, so you fill up with 0, right? So the answer is what? Negative 200. That's how you do decimals. I'm not going to test you on decimals yet. Until the end of this class, we need to use decimals to solve problems. So you need to practice first. Now we don't emphasize on the decimals. We'll do some fractions and regular numbers. So let you get familiar with how things work out for doing what. What we have been learning right now, we say solving linear equations. That's what we are doing. Let's try some more decimals. Okay, practice some more. Draw the line. Make each side simpler. So, by distributing, right? So what do we have? 0.5y plus 0.5 times 100. 0.5 times 100, right? When you multiply, what do? You line up at the end. When you add, you line up your decimal points, right? So for multiplication, you lined up at the back. So you just multiply regular way and decide how many decimal points do you need, right? 1 here, nothing here, so you need a 1. So it's a 50, right? So we put it together, 0.08y. Then what do? Combine like terms. Make each side simpler. So this one would be 0.58y plus 50 equals this, right? Then we move number away by minusing. So what do we have? 0.58y equals 23.2. Then what's your y? You divide, right? 0.58, 0.58. So that's your y. How do we divide this? So That would be 23. Let's do it again. 0.58. Right? When you do the division of the decimals, make the denominator whole number. So you do regular division. If you move 2 spots here, you move same thing, 2 spots. So that's your final position for the answer as well. Then fill in 0 if necessary. So 58 can go into 232. How many times? Let's see, about 4 times, right? So 4 is 232. Then you need to finish up by all the way to your decimal point. So you put a 0 here. So your y is what? 40. Are we good? Let's see other conditions. Special conditions. Okay, everything has exceptions and particular conditions. So let's describe them. And what we have been doing is we find the answers for x. X equals some kind of number, right? Either regular number, positive or negative, or fractions sometimes. The answer can be fractions. However, let's take a look at this particular case. Sometimes nothing will work. Then you will have no solutions. You will always have exceptions most of the time. Okay? So, practice. You need this one to be able to survive this class. This would be your section 2.1 to 2.5.